Hey ladies and gentlemen, welcome back. So this is part 2, and in here we're going to learn about variables and data types in Java. So I'm using a different text editor today, but you can still use Notepad, no problem. This is just a better version of Notepad. It's just another text editor. I'm using Sublime Text. You can use that text editor, or you can still use Notepad. There's no problem with that. It's just that this one helps me out while I'm typing a bit more, so we can do things a bit faster. So Sublime Text can be downloaded for free. Just type Sublime Text download and you can follow along, or use Notepad. So what are variables really in Java? Now, a variable is a way to store information because it can be helpful in a programming language to store things. Let's say you ask a user to give you their name. So you say, enter your name here, please. And then you can use that to store. You can store that name in a variable and then use it later. So we're going to see how that can work. So I'm going to come here to my project folder. This is Java projects. Now, Hello World is a bit too long for me to type every time I'm compiling this app. So I'm going to create a new folder and create a new project. I'm going to call it app for simplicity. That's easier to type. I think we can all agree. So app there, capital A, PP. And then let me create a new file here and then save it in my project app folder as app as well .java. Okay, so capital A, and then of course I'll need to create a class as this is required in Java. So I'm going to create a public class and say public class. I'll call it app, just like the file name. This is also required. And then I'm going to do create a main method. So we need a main method in the class that we are starting running the application. So a main method is required, at least one main method per project. So I'm going to say public static. This one has to be static, and then void means it returns nothing as a result, but we're going to learn that a little bit more when we talk about functions and methods. So public static void main. In here we have to put capital S string with 2 brackets to show that it's an array, and args like that. Okay, so this you can actually save in a separate file as the beginning, because you have to type this to start with all the time. So you can save this as a separate file. That way you just copy and paste this data, because this will be we'll be typing this every single time. All right, so once we get here, as you can remember, we can do system.out print like that, and then we put a string and just say hello like that. So double quotes there for a string and then hello like that. So if we try to run this application is just going to print hello. So let's do that just to see that things are working as intended. So I'm going to go in my app folder and copy the path to that so that I can pull it in my console. So here I'm going to go cd, change directory, and then put /d to show that we are changing drives, and then I'll go to that one. Then let's clear the screen. Now we are in the app folder, so I can do java c to compile and say app.java. That's the file we're compiling. No errors we're seeing. Let's just now type java app to run the application, and you see it says hello. So if you see that, everything went well. So now let's look at what a variable is. Now, so if I want to store something to use later on, then I can save it in a variable and then use it later. So to save something in a variable, use the equal sign. So a variable needs a name. So there are 2 things. It needs a name, it needs a value, and there should be an equal sign to assign one of those to the other. So the name, we're going to name it A. I'll put an equal sign and I'll put a value like so. Semicolon after every line. So here I'm just saying inside A, put 4, because now A is equal to 4. So I'm just saying get this number 4 and put it in a memory location in the computer and call that memory location A. So you can call the memory location anything you want and then just say is equal to 4. As long as you, so whenever I need this number 4, I just need to call this thing again and I'll get 4. So if I can also say A is equal to hello like this, and then here tell it to print whatever is inside A instead of the actual text there. So this is gonna work just fine, except Java is what is known as a statically typed language, which means you must tell it what data type you are putting in a variable before you put it there. So here, if I'm putting this is a string, so I must type here and say string A is equal to hello, and then echo out or print out hello like that. So this is gonna work just fine. So I'm telling it that this A can only store a string in there. So if I try to store a number here like this is going to be a problem. It will cause an error because I'm trying to store a different data type to this one. Okay, so you can test this real quickly by just running javac and do the compilation, and then once you are done, you do java app to run the app, and you still see the word hello there being printed to the screen because that's what is contained inside A, like that. Now string is not what is called a primitive data type because there are two types of data types in Java. Now when I say data type, I mean the type of data you're going to put in every variable that you can create. There are types of data. Now because since Java is statically typed, you should tell it what you're putting in that location before you put it. Now the reason for that is that it needs to know how much space to allocate for that thing. So for example, if we say here are the primitive data types, for example. So there's a Boolean, there's a byte, a char, a short int. Now if you notice, all these have a specific location size that they have. So for example, this one is 8-bit, which is equal to 1 byte. This one is 2 bytes, which is 16-bit. So how much can you store in 1 byte? You can store positive 128 to negative 128. Any number in between these two, including these, can be stored as a single byte. So if, for example, you want to store a number of days in a month, for example, you know that this number will not go beyond this. So you can use a byte instead of an int, for example, because this one will need more space to be stored. So because the computer can't really know, let's say, for example, you say A is equal to 1, right? 1 may change over time as you run the program. You may put another number in there, like 10 or 20, but the program will never guess how large the number you're going to put in there unless you tell it. So if you just put a number like that, it's going to assume it's an integer or something because this is usually the default for numbers. And then it will put 32-bit of memory to keep that number, which is quite a lot if you only needed 8-bit instead, because that number will never exceed this value. So this is why these primitive types are given, so that you can be more efficient with memory and store, put less. So if you know it's going to be, these are the limits here. There's 32 minus 32,000 to positive 32,000. This one can store 2 billion, this number here. And this one, I don't even know what this number is, because a billion is somewhere here, I think. Trillion, I don't know what number this is, but that's how long it is. This is 8 bytes. So imagine storing a memory location with this much space when you only needed 1 byte. This is a waste of memory. So you have to look at these guys to know what you're going to store. So this is about these guys here. These ones are pretty much numbers, except for char here. So I'm going to talk about char as the last thing. But think of these: a byte, just a number; short, int, long, they are all numbers. These ones here are also numbers, but these have decimal places. So if you want to store a number with a decimal point, it has to be either a float or a double. A double is more precise. So if you're dealing too much with precision, let's say, for example, you are planning a trip to the moon for some reason, and you need to know specific values so that you plot a specific path to the moon. You wouldn't use float in that case. You'd probably use double, because this one has more precision. More decimal places you can hold, the more precision you can have. So if you're dealing with money, for example, you better use a double. But if it doesn't really matter, you just want an approximated, the precision is not so important, then you can use a float, no problem. But because both these use decimal, you can store decimal numbers there. So we're going to see examples of all this right now. And then a Boolean, only one bit, because it only stores true or false. This is all. So let's see examples of these here, the bytes, and how you would store that. Now, the same way I did this, instead I can store a byte by just saying byte A is equal to, and then I put a byte in there, because it can go up to 127, right? So this is valid syntax, or it can be 100, for example. So byte A is equal to 100. This is fine. It will work just fine. We can test this. It's better to test than to just speculate. So let's compile. I typed the wrong thing. It's Java C. Okay, we've compiled. Now let's do Java and then run the app. You see it shows me 100. No big deal there, right? So that's how you do a byte. Same with every other thing. You can say short. The only problem would be if you want to store a number like 1000 in a byte, then you're going to have a problem, because a byte goes only up to 127, right? So say Java C, and then we try to compile this. You will see the error that we will get. It says incompatible types. Possible lossy conversion from int to byte here can happen, because if you put 1000 inside a byte, it will throw away the other 0, and just actually what it will do, it will just get the maximum allowed number and store a 127 instead of this 1000. So it's warning you here and saying, if we put this 1000 in a byte, it will become 127 instead of this, because a byte can only hold up to that much. So that's the error there. So if you're unsure of the number, just put an int instead like that, because int usually is good enough. You'll find that int, normally you not go beyond this number whenever you're dealing with numbers and stuff. But if you're sure it will be bigger than this, then you can use a long. If you want decimal places, you use that. So everything will work. You just need to replace this with the right keyword. Except though, when you're using float, that doesn't seem to work. So here I'm going to do float and just put a bunch of decimals there for effect. Let's try this one and try to compile. So Java C app.java. So it shows me an error. It says incompatible types, possible lossy conversion from double to float. Okay, so it's considering this a double. But what we're going to do is cast it as a float by putting a letter F here. I don't know why we have to do this, but hey, that's how we have to do it. So let me try now and compile. I'm going to say Java C and then say app. Let's see if that solves the problem. And it does compile. And if we try to run it, it works. Look at that. But every other type, you don't need to do this. So here we're going to do double. I can put D, I think it works, but I don't need to. But you can put D like that. I think that will work. Let's put this as B. Now, since I've already declared A as a float, I cannot re-declare it again as a double here. This won't work. I have to use a different name for a different location. So let's put B there. Let's print A and print B. Now, I want, if I print these, they'll print right next to each other. So let me show you that. I'm going to put a 2 here so that we see the differences. So then let's try and run this again. Java C app.java. Okay. Then let's do Java app like so. And you see these numbers are printed right next to each other. There's 1000 up to there. This 2000, that's a different number. Now, if you want them on separate lines, you use the print line instead function. So just put ln at the end, That's the print line function. Then they'll print on separate lines. So let's try this out. I'm gonna do Java C app.java. Sorry, you can press F3 to repeat what you typed last time to save time. Okay, then let's do Java and then app, like so. So now you see it prints on separate lines. This is what the print line would do. So usually you use this one, I guess. So this works pretty much okay, like that. Now if we go back to the types here, you can then use long and so on. Now the thing is, if I cast this as a let's say here, the same number here, I put int instead, the only thing it would do is it will get rid of the decimal point. It will just show as 2000. That's what will happen, because an integer can't hold decimals, so it will just get rid of that. So let's see if this works. So by the way, if I put 2 slashes like this is how I comment out a line. So it means this line will not work. It becomes a comment. You can do that. If you want to comment out many lines, you can put a star like this and then put another star and a slash to end the commenting. So this line here will be ignored just for you to read when you want to. So I'm going to put double slashes there to comment this out so it doesn't run, so that B is only declared here. So let's see what will happen to the decimal place of B once we print that. Okay, so Java C app.java. Okay, so now it says incompatible types, possible lossy conversion will happen here, blah blah blah. So that's what's happening here. So if you're expecting decimal places, use either double or float for that. Okay, so let's look more here at what are we remaining with. I think this is what happens here. Now, of course, with these numbers, you can do arithmetic with them. So you can say, for example, int a is equal to 5, and then we say int b is equal to 8. And then finally here, I can say int c is equal to a plus b, like that. This is a valid syntax because now I have a location memory called a, which has a 5, b has an 8. So when I try to add these two, they are going to add together, and then c will be the result of that. So I can print out c, let me remove this, which will be 5 plus 8, and it will give a result. So you can try and run this as well, just to see it in action. And then finally, Java app, and you see the answer is 13. Simple as that. Now finally, let's talk about a Boolean. A Boolean is just true or false. So Boolean will store a true or false. So you type it like this, Boolean, let's say E is equal to true, like this, or Boolean F is equal to false. So notice that you don't put quotes around these. These are literal values, true or false. So we will see later how these can be used. For now, we can ignore them. And then finally, there's this char here. Now, if you notice, char is 2 bytes and short is also 2 bytes of space. So you'll be asking why, what's the real difference here? There's no real difference. Both of these just store the same, or the difference actually is here, over here. So you see, a short can have negative numbers and positive numbers to this. If you multiply this by 2, you get this value. So a 2-byte memory location will store this number of numbers, 65,000 numbers you can store. But because this one has to store negative values as well, that number is cut in half for the positive side and half for the negative side. That's why this one seems to store half of this one, but actually it stores the same number of items, just that some are negative, some are positive. A char is always positive. A char is used specifically to store letters or characters, not really letters, but characters, because even Chinese characters are stored. Even emojis are characters as well, and they are stored in as a char. So it's 2 bytes because there are so many characters. The reason it's 2 bytes is because Java uses what is known as Unicode, which is a universal encoding method which was invented to make sure that there are no problems with encoding. Because long ago, what would happen is, if let's say an American makes a computer, they'll say, because a computer only stores numbers, keep that in mind, it doesn't store letters, just numbers. So a group of zeros and ones make one number. So a group of zeros and ones will make one number, another group of zeros and ones, another number. But then they thought, what if we map numbers to letters? So let's say, for example, number 1 represents letter A, number 2 represents letter B, and so on, like that. But then maybe once we reach the alphabet, which is 26 letters, right? We go 27 becomes a small letter A, 28 becomes a small letter B, and so on. And then once we reach the end there, we can keep adding numbers, and then we get to symbols. Percent sign could be maybe 123, could represent a dollar sign, and so on and so forth. Now the thing is, at first they were using just maybe 4 bits of data, or let's say 1 byte of data to store that. And that was enough because one language, you can't have more than that many characters. But then they wanted a system to include every language on the planet. So instead they decided 2 bytes should be used to store a single character. So 2 bytes is 16 bits of data. So you need 16 zeros and ones to represent this number of characters. So now Unicode can store 65,000 different characters. This will include every language on the planet, which is a good thing, right? That way there's no confusion. Regardless which computer you're using, it will interpret the characters correctly. So here, let's see how char can be used. So remember that deep down, a character is just a number from 0 to 65,536. It's just a number. But then you can tell it to show you the character that number represents. So let's come back here for a second and see. If you say char, let's say char A here, let's put A in there. Let's remove these other guys. Char A is equal to 5 like this. Let's just set it to 5 and see what that does. What does it show us? So I'm going to say Java C app.java, and then let's do Java and then app again. So look at that. It shows me the actual character instead of the number that I put. And look there, that's the character that you get from that number. So let's try if I put 50, for example. It's a character and number 50 like that. So instead of it being showing a number, it will show the character version of that number. So let's try again. I'm going to do Java C and say app.java, compile, and then run the app. There we go. That's what it is. That's the character that it represents. What about 128 or 100? What does it represent? So you can keep going here and check out what character is represented by those things. So there are numbers, letters, symbols, emojis, etc., etc. So, and then I'm gonna go Java app. So it's letter D, small letter D. That's 100. So that's how you can check what the character representation of a number is. So with this, you can either represent this as this, or you can use hex values to represent. You can do it like this. You put a /u. That means you're about to use a Unicode number. So instead of you putting a number like that number, you can put a hex value instead. So hex is from 0 to 15. So from 0 to 15, and the numbers from 10 to 15 are represented by letters A to F. So if I put A, like that, this is a valid Unicode value. That just means 10, 10, 10, 10. That's all it means here. So this is a specific number here. If I put FFFF, this is the maximum number represented by a character, because that's 15 times 15 times 15 times 15. So we can see that in action here. If I do, this is the number, right? 65,536. So if I do, no, it's actually not 15, but 16 times 16 times 16 times 16 will get to that exact value. So when I do this, F is 16, 16, 16, 16, and it gives me the maximum allowed. Now this character, obviously, I don't know if there's even a character here because there are spaces. Char represents such a big number that we haven't yet, I think some numbers don't even represent characters yet, or something like that. So if I try AAA like this, let me see what this will show me. So I'm going to do Java C and then app.java, and then here I'm going to run the Java app. So it puts a question mark here simply because it can't actually show you the character. The command prompt doesn't know how to interpret it. That's why it puts that question mark. But otherwise, this is a valid character. If you want, you can put 0, 0, 0, let's say 2, a lower number. Let's see that as the last example. Okay, and then let's run it. Okay, so you see it's an emoji of some kind here, a funny face there. Okay, so that's how these data types work. The others are not primitive data types, and the reason they are non-primitive is because they are created from the foundation of these. For example, a string is just a list of characters. So if you get 10 characters and put them together, that becomes a string. So what the Java creators did is they created an object that handles that kind of thing. So every time you say something like what I had done in the beginning, where I say string A is equal to, like this, what it actually does is it grabs each character like this and stores them in an array of chars, and then it's called a string like this. So string is not really a primitive type. These are just chars put together in close proximity to make one sentence or one word like that. So the primitive version of this is a char like that. So this is a complex object and not a primitive like a char here. It's the same with arrays. Arrays are created from primitives depending on the type of array, and objects are classes that hold functionality for things like strings and the like. So hopefully you have learned something new in here, and this is more theory than practical, but we'll get more practical as we go on, and I will see you in the next video.